Welcome back to Startup Hack. With my 25 years of development experience, here at Startup Hack, we turn beginners into full-stack developers in as little as 3 months. Today, we're going to dive into the solid principles that make it easy for a developer to write extendable code and avoid common coding errors. So let's go ahead and get started. Do you want to start a lucrative career as a software developer? With our amazing material and awesome tutors that are available for one-on-one training, we can help make sure that you're successful. The course teaches technologies that companies use and want software developers to know. You can complete the course in as little as 12 weeks, so check out startuphack.com today. And make sure to check out the link to the coding samples. We always provide the code along with our videos, so check out the link below. Also, make sure that you like and subscribe to the channel because we bring you a lot of great tutorials and tips that every developer should know. Now let's get back to the code. All right, so let's dive into the solid principles. So let's talk a little bit about solid. So what is solid? It's an acronym that we can see here on the screen. So S stands for Single Responsibility Principles. Each class should be responsible for only one part or functionality of the system. O stands for Open Closed Principles. Software components should be open for extension, but closed for modification. You should be able to extend class behaviors without modifying it. Liskov substitution principles. Objects of superclass should be replaceable with the objects of its subclasses without breaking the system. I stands for interface segregation principles, making fine-grained interfaces that are client-specific, meaning interfaces created should focus to individual clients. And D is dependency inversion principles. Ensure the high-level modules are not dependent on low-level modules. So solid principles make it easy for developers to write easily extensible code and avoid common coding errors. These principles have become a fundamental part of object-oriented programming. In the context of .NET development, adhering to solid principles can lead to more modular, flexible, and maintainable code today. So we're going to dive into each of these now. So let's talk about single responsible principles. So SRP states that a class should only have one reason to change, meaning it should only have one responsibility. This promotes modularization and makes the code easier to understand and maintain. So the key idea is a class should do one thing and should do it well. So now there's a real-time example that we have here. So think of a chef who only focuses on cooking, not managing the restaurant or delivering food. So for our practical coding examples here, we can see the before SRP, and then we can see after where we have the actual public properties. So in this scenario, the report class has two responsibilities: generating a report and saving it to a file. This violates the SRP. After applying SRP, the picture on the right, now the report class is responsible only for generating reports, while the report saver class is responsible for saving reports. Each class has a single responsibility. So according to SRP, one class should take one responsibility. Hence, to overcome this problem, we should write another class to save the report functionality. If you make any changes to the report class, it will not affect the report saver class. So let's go to the next one. Open Closed Principle, or OCP. The Open Closed Principle suggests that a class should be open for extension but closed for modification. This means you can add new features without altering existing code. So the key idea is once a class is written, it should be closed for modifications but open for extension. So some real-time examples: your smartphone. You don't open it to add features, you just download apps to extend its capabilities. So we can see that on the before, we can see the example, right? So we can see a rectangle class that has a property of a double of width and height. Then we see the area calculator class, which calculates the area by using these properties. So the after would be that this design may become problematic when adding new shapes. Modifying the area calculator for each new shape violates the OCP, as we see on the left. So we can see that after these have been split out, and you can see the implementation in each of these while it inherits the I-shape object, the I-shape interface, excuse me. By introducing an interface, I-shape, the new shapes like circle can be added without modifying existing code. Adhering to the OCP, now according to OCP, the class should be open for extension but closed for modification. So when you introduce a new shape, then just implement it from the interface I-shape. So I-shape open for extension but closed for further modifications. All right, so the Liskov substitution principle states that objects of a superclass should be replaceable with objects of a subclass without affecting the correctness of the program. So you should be able to use any subclass where you use its parent's class. So a real-time example, you have a remote control that works for all types of TVs regardless of the brand. So we can see that before applying for LSP, here the Penguin class violates the LSP by throwing an exception for the fly method. Now after applying the LSP, by introducing the iFlyable interface, both Bird and Penguin adhere to Liskov's substitution principles. According to the LSP, a derived class should not break the base class's type, definition, and behavior, which means objects of a base shall be replaced with objects of its derived class without breaking the application. This needs the objects of derived classes to behave in the same way as objects of your base class. All right. Interface segregation principle states that a class should not be forced to implement interfaces it does not use. This principle encourages the creation of small client-specific interfaces. So the key idea here is a class should not be forced to implement interfaces it doesn't use. So let's talk about a real-world example here. So you sign up for a music streaming service and only choose the genres you like, not all available genres. I know some of you Taylor Swift fans out there would love to have Metallica added to you, and some may not, to your playlist. All right, practical coding examples. Before applying the ISP, the robot class is forced to implement the eat method, violating ISP. But after applying for ISP, by splitting the worker interface into smaller interfaces, iWorkable and iEatable, classes can implement only what they need, adhering to ISP. So according to LSP, any client should not be forced to use an interface that is irrelevant to it. In other words, clients should not be forced to depend on methods they do not use. All right, our last one of the solid principles is dependency inversion principles. Suggest that high-level modules should not depend on low-level modules, but should depend on abstractions. Additionally, abstractions should not depend on details. Details should depend on abstractions. So the key idea here is high-level modules should not depend on low-level modules. Both should depend on abstraction. So a real-world example, you're building a Lego tower. The bricks, the high and low-level modules, connect through smaller bricks, abstractions. So now let's look into the coding example here. So before applying DIP, applying DIP, the switch class directly depends on the concrete light bulb class, violating DIP. After DIP, by introducing an interface, iSwitchable, the switch class now depends on abstraction adhering to dependency inversion. So according to DIP, do not write any tightly coupled code because that is a nightmare to maintain when the application grows bigger and bigger. If a class depends on another class, then we need to change one class if something changes in that dependent class. We should always try to write loosely coupled classes. So what are your thoughts? Those are the solid principles here. Do you use solid principles? I'm curious to hear your answers. So what are your thoughts? I'd love to hear your comments down below, and I love having a good discussion. So make sure to leave a comment and make sure to like and subscribe. Here at Startup Hack, we love training software developers. With my 25 years development experience, we take people with zero experience and help to train them to be ready to start as full stack developers in just as little as 3 months. So make sure you check out startuphack.com or check out the link down below. We'll talk to you guys next time. Make sure you like and subscribe to the channel because we bring you lots of great tutorials and tips that every developer should know. See you next time.